Okay, yep. We can do your question first. So are you going to upload the question to slide 3? Nice. Okay, nice. Mm. So you managed to do it or no? Mm. Mm. Actually, the part 3, right? The part are you talking about part 3? Okay, actually part 3 is always the hardest part. Okay, it's always the hardest part to prove. Okay, so I can only share with you some of uh, my thinking processes, so that next time hopefully you get to adopt the same approach, and then whenever you face this kind of question. Okay. Uh, okay. So you prove that BD is parallel to EF. BD is parallel to EF. Have you proved that? And then it's always good. It's always good to label with pencil. Okay, because uh, in the event that you make mistakes by using pencil, and you can still erase the still erase the all the tracings and your markings, right? But if you use a pen, if you make a mistake somehow and you messed up the figure, which you don't want, right? So I would suggest when you label this figure next time, please use a pencil. Okay. Okay. So you are asked to have. Okay. So you need to prove that CFD. Where's CFD? CFD. Okay. So in a way, right? Once you get the okay, maybe I should talk about how you should prove the two triangles are similar. Even though you get it right, but getting it right doesn't mean there's nothing to learn. Okay, so how to prove two triangles are similar? I think generally you should get the. So what I will do is I will get the I will get the CFD out. CFD is here. Okay, I'll get the CFD out, and AFC. Where's AFC? AFC. So I will get the AFC out, but I will follow CFD is AFC. So AFC is A. Even though AFC looks like this, even though AFC looks like this, but somehow I need to match it point by point. So this is my point A, use here. Then AF. So CFD is AFC. Okay, good. So this is my point C. F is here. C should be that point. Okay, then now you are asked to prove that FC square. Why you go and square this? Is there a reason you square this? Mm-hmm. Yeah. Mm-hmm. 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 I got it. So in a way, right? FC minus. Okay. So there are a few ways to look at this. So basically, you have this FD times the. You have this FD times the DA, right? For this one. Yep. I'm looking at your working. So, right, is equal to this. Actually, what you can think of is like FC square minus FD square. I think one of the approaches you can see as FC minus FD and then FC plus FD because this is equal, right? Okay, so FC minus FD, where is FC? FC minus FD. So can you kind of like prove that FC minus FD is your DA, and then your FC plus FC plus your FD is your looks like I can't, right? But so this is one way to look at it. Then the other way you look at it is so what I can see here is FD over FC is equal to DC over CA is equal to FC over FA, right? Okay, so can you see that can you see this one? So I will pick this and this, okay, because I see that FD over FC is equal to FC over FA. So in a way, right, I can see that FC square is equal to FD times FA, right? Yeah. So FC square is FD times FA. Okay? And then our FD. Can I just look at FD? Okay, so now your this so in a way, let me see. Your this is FC square and then FD times DA. Which one is DA? DA. Is there a similar? Let me see. DA DA is okay. So in a way, DA is equal to this FA minus the DA, this one is your FA minus the FA minus FD, right? Okay, so in a way, your FD, your this FD times DA, right? You can see it as FD times this one, FA minus FD. So which is FD FA minus FD square. Okay. So can you see that? Okay, I think I have kind of like helped you get things done already. So your this FD equals to FA, which is the right hand side. I help you prove that it's going to be equal to I have you prove that it's FD times FA minus FD square. So in a way, right, you have this FC square minus FD square. So yes, because just now I have proved that FC square is FD times FA, right? So, proof. Okay, here. So FC square is equals to this FDFA. Okay? Okay, yeah, so done. Alright? Alright, that's it. Okay? Mm. Next question. Any other question? Okay. So then we can look at our. Do you have other question from your school before we look at the before okay before we look at the homework, like the Anglo Chinese one? Let me take a look at the Anglo Chinese one as well. ACS, right? Have you finished the homework 3, which is Xing Ming one? That one, let's see. Never mind, let me just launch both of them and then I want to see the. Okay, launching on my side. Hold on. Launch on my side already. Hold on. So I'm looking at Xing Ming one. Okay, let's see Xing Ming one first. Oh, okay. I'm not sure if we talk about this. I think this is quite interesting. Okay, I'm trying to upload to slide 4. Let me clear slide 5, okay? Sorry, slide 5. Okay, I'm trying to get it to this. Slide 5, huh? Okay, so if you are looking at slide 5, did we talk about this question 5? Okay, we did. Okay, good. So, yeah, I find that this question is very, very interesting for the logarithm question. Then, let me see. Okay, so there is a similar question to your this plane geometry. So maybe I can test you. Same slide, slide. So we just take this as a yeah. You want to share with me? Let's see the midpoint theorem and the intercept one. Did you write it somewhere already? And by the way, I see intercept theorem in your part 3. And hold on, your intercept theorem, can you explain using, okay, go to slide 3. Can you explain your intercept theorem to me? So maybe I can shed some light on whether your this intercept theorem is a derivative of something else. Okay? Here. Okay, I'm going to erase my this red, my markings first. Okay, yeah, good. Yeah, go continue. They are parallel. Mm. Can you use a different? Can you use a different color to blue? Yes. Mm. Mm-hmm. And by the way, what you are trying to tell me is, uh, this triangle and this triangle, they are similar, right? And then therefore you tell me AG over GC is equal to AD over this DF, right? Okay, so let me see. Mm, so your AG over the AC. Okay, so actually using the similar triangle property, your over the AG over the AG over, I will say, is A. Okay, I'm not going to use this. So AG over AC is equal to AD over AF, right? Using similar triangle, so AGD, then this is ACF. Yeah, and then your this AG over GC. So that means it's in between. Um. Okay. So. Mm, okay. Okay. Good. Interesting. Okay. So this is what intercept theorem, right? Mm. Then the next one. Then the next one. Which one? Mm. 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 I'm gonna erase my stuff. So where's the midpoint theorem? Can you explain? Yeah. Mm. Okay, can you use a different color so that I can see which one you are pointing at? I cannot see which one you are pointing at. Mm. Yes. Mm-hmm. 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 Mm. So which is BE is half of CD. Oh, okay. Okay. Sometimes more rules doesn't mean better, because you just don't know which one to use. That's also a problem, right? Right? Okay. So BE is half of CD. Okay lah. So in a way, right? In fact, for this one, right, you don't have to use this also, because I think it makes sense. Because what you are trying to use here is, okay, this one, okay, and this one, right? So if AB is over AC, right, should be BE over CD, right? Alright. So therefore, you know that AB and this is 1 to 2, right? So therefore, this is half also lah. So I think this one is not so useful also, because you can somehow prove it on the spot. Does it make sense? Yeah. So okay, why I don't want you to rely on rules. So I want you to try to uh, prove it on the spot. Okay, instead of remembering all the rules, because sometimes if you try to remember the rules, and when I ask you to remember so many rules, and you tend not to remember all of them, and so it's good that you can always come get it on the spot, right? So for this one, it's not so useful, I will say, because you can somehow prove it on the spot. Okay. Okay, but good to know. Good to know. Yep. Okay, thanks. Okay, so yes, go to slide 5. So there's a plane geometry question. Yep, slide 5. Please do it. Please do it over here. Is your laptop running on Mac or Windows? Oh, okay, no problem. 所以是 90 degrees right? Wait, you mean the EB? Okay, where is EBG? EBG? No, this is your this. You can use the internal angle. What is 90? The bottom one is you mean here? Here is given or labeled by you? This is labeled by you, is it? Oh, okay, labeled by you. So this is your tangent to the. Is this the diameter? dB. Let me see. So how do you tell this is the diameter? There on the circumference. Okay, good. Okay, good. Yep. So basically, if this is the diameter, so you can use the tangent to the radius. Tangent to the radius is 90 degree. Correct. Yeah. Angle B is common. So therefore, that's how you prove. So this is common. Okay, so this one has to be the also the same, right? So that's how you 3 mark easily get. Yeah, BD times BE, correct. So basically you are saying BC over BD is, no, this one should go up. This one should come down. Should be BE over BC. Yeah, I think, yep, easily 2 marks. So one way is you can, okay, so one way is you prove two the two lines are the same length. The other one is you can prove that the two angles are the same. So you either prove angle 1 equals to angle 2, or you prove the side is the same. Understand? Yeah, either one. So this is line 1, this is line 2. I think you should use the angle lah, huh? In this case. Why leh? Actually, if you are asked to find the it's an I source, you have to prove it. Otherwise, you can't. You say means you assume, right? You assume without reasons. That means it's just your assumption. I can assume something else, right? Right. So by the way, ABC is an isosceles triangle. So are you trying to tell me this is equal to this, or this is equal to this? I don't know. So you have to prove somehow. Mm-hmm. But I think somehow you can prove that this one is equal to this one, right? So therefore, this one is equal to this one because of same segment, right? Mm. So therefore, this one and this one is equal. So if this one is equal, so that means this is an isosceles triangle. Yes. Okay. So you make use of the properties of circle, right? Okay. Good. Okay. So let me clear this, and then actually I saw a very interesting question. It's about equation of circle. Do you have problem with equation of circle? I, yeah, I think so, right? A bit, right? Yeah. I remember we did a equation of circle the other time, and then equation of circle. Yeah, this is the one. Yeah. So to do this question, you have to try to sketch it out. Need not to be very accurate, but somehow you need to sketch it out so that you have some sense how it looks like. Mm-hmm. Yep. Yeah. Exactly. Yes. So if you were to, so you try to sketch it out. Okay. Maybe I should leave it to you, because ultimately you have to do it on your own. Okay. So I just try to leave it to you and see if you can come up with something. You can make use of the tool here, but they don't give a straight line. That's pathetic. Actually, I tried to make a very thin bar the other time, but somehow it doesn't work. Then, yep, nice. Okay, this is a good idea. Yeah, nice idea. Yeah. I probably can think. Yep. Thanks for your this idea. Why so? Ah, okay. Yeah. Yeah. Okay. did you insert a picture or something? Okay, nice one. Actually, you can get a good circle from here. Yeah, nice. Yep, nice. Yeah. So this is your A, right? So which means this length is the radius, right? Which is A minus 3, right? So this one is also the radius. This has to be A minus 3 as well, right? But actually this is A, right? Because this is 0, this is A, right? So wait, let me see. They say what? X coordinate is A. So this is A, then this is your Y, right? Okay, so therefore this is A. So therefore the radius is A. Okay, and this is your A minus 3, right? Which is also has to be A, right? Does it make sense? Oh no, this is Y. I'm sorry, this is Y. Yep, yep, this is A, yep, this is Y, yes. So therefore your this is A, right? So Y minus 3 is equal to A. So Y is A plus 3, right? Right? Okay, this is the radius, which is A. Then this has to be A also, right? So this A is equal to, actually this A is equal to Y minus 3, right? Huh? So let's say if you this is Y, this is 3. So what's the difference here? It's Y minus 3, right? Yeah, so therefore Y minus 3 is equal to A. Okay, so therefore your Y is actually A plus 3. So you can write A plus 3. Does it make sense? Okay, good. Okay, good. Continue. So write down the largest possible y coordinate of the C in terms of A plus 3. Right? 1 mark done. Right? Now you have 8 and 12. Where's 8 and 12? Let me get rid of this. I thought you can make use of this picture and then just tilt this picture so you get a very good line. Yeah, why not you make use of this picture? Just get another picture in and then um, 8, 8, 12. Okay. Mm-hmm. Mm-hmm. Okay. 8, 12 and then And then the center of the C is below and to the left. Oh, okay. X minus x, actually it's x1 minus x2 square. There are two formulas. I don't know which one you want. So which one you want? Yeah. Mm-hmm. 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 Mm. Yeah. Mm. Mm-hmm. And by the way, how do you know how I remember this formula? Pythagoras theorem. Because let me just, can I go to slide 6 just so because I don't want you to memorize, okay? I want you to get it on the spot. So can you go to slide 6? Okay, so let's say you have this, right? So let's say you are asked to find, okay, let me give you this point. Let's say this is okay, let me just, let's say this is so this is your 3 and 2, right? And then let me just get one point. So let's say this is, I don't know whether my this point is correct or not, but let's assume it's correct lah. Huh? So let's say this 1 and 1. So in order to get this right, so you can see, how do you get your this is the radius, right? Yeah, I use Pythagoras theorem. Can you see that Pythagoras theorem r square is equal to, so this is 2 minus 1, and then you square this, and then you use 3 minus 1, you square this, right? So that's the reason why so basically this is r squared. Can you see? That's why, can you see that this is my x1, this is my x2, so this is my y1, this is my y2. So can you see x1 minus x2 square plus uh, this this is y1 minus y2 square is equal to r square. So this is the formula. So you can, so what I'm trying to tell you is the formula from this, I mean this formula for the equation of the circle, right, actually comes from the Pythagoras theorem, which is this. Okay, so next time you don't have to ask me, right, for the so-called, for this formula. I think you can get it from the spot. So in fact, uh, I'm trying to let you not memorize as much as possible. Okay? Yeah. Okay. So you use your calculator to solve this instead of factorization method to get your A lah. So what your calculator give you? Mm, mm, mm. Okay, looks good. Yeah. Mm, mm. I mean, based on the sketch, right? A is 5. In order to in order to be in order to be yeah, yeah, exactly, because of this because of this statement. Mm. So you reject the, yeah, 29. Yeah. Pardon? You reject it, because the center of C lies below, and that means you cannot accept it. Yeah. Mm. Okay, now it's good. So A equals to 5. So the equation of C, yeah. So the equations of C is so basically your this is 5 and 8, right? So what's your this question? I mean, this what was this equation of C then? Oh, you prefer this? You prefer this? Actually, I prefer this. They ask for me. They ask for the equation, right? I prefer the x1. Okay, so the center is 5 and 8, right? So basically, you x minus 5 square plus y minus 8 square equals to 25. Yeah. Oh, this 25 is r square, so it's 5 square. So I prefer to write it in this manner for the equation of the C, instead of the x squared plus y squared, that one. Okay, you can write that one, but basically that one is the expansion. That means you will expand. If you expand this, you will get that format, which I don't prefer that format. You understand me or not? Ah, I prefer to write it in this manner. Okay. So of course there are people who expand this out, expand it, and then you will get that format, but I don't prefer that. Okay, never mind. So yeah, one mark gone, done. Equation of L, this one, right? Yeah, it's a tangent. Yes, it's a tangent. You need the gradient, because equation of a line is y equals to mx plus c, right? So your job is to find your m, and your job is to find your c. That will give you the equation. Yeah. Okay, this is 90 degree. So in a way, right, your this let's say you can find the gradient of this m1. So your this m2 is you m1 times m2 is, yeah, -1. Yeah, that's how you get your m2 lor. Okay. Yep, yep. Continue. You can erase. You can erase your this work already. No need already. I'm also helping you to erase some of your work so you have space. Actually, strictly speaking, it's -4 -3 lah. Huh? Yeah, yeah, I agree with you. Like, but strictly speaking, your this one you give you -4 ma. This one you give you -3. So if you want to show 4/3, you should write one more step. Understand? Or unless you write in this way, and like in this manner. Yeah. Okay. Okay. Eh? What is this formula, by the way? Oh, okay, got it, got it. Okay, thanks. Okay, got it. Okay, nice one. Okay, good. 3 mark here. Yeah. So you just need to find the, yep, the center. Yeah. 5 and -8, right? Right. Yeah. Okay. So done. Okay. Very good. Okay. So yeah. So it's good that we go through this exercise so that I think you build some confidence in uh, equation or circle question. Okay. So the most important thing when it comes to this kind of question is you need to be able to sketch it out. Because if you cannot sketch it out, you try to do it purely in your brain, right? It doesn't work. Okay. It doesn't work. All right. So all right. So let's go and have a 5 minute break. Then we come back. We'll look at other questions. All right. Okay. So see you in a while.